Hello everyone, I am Aher Suvarna, Assistant Professor from Department of Electronics and Computer Engineering of SND College of Engineering and Research Center, Yeola. I am giving a presentation on topic Sensor and Applications under the guidance of respected Principal Dr. D.M. Yadav sir. First we will see what is sensor and its applications. Before going to applications, let's see what is the definition of sensor or what is a sensor. A sensor is a device that detects physical, chemical or biological signals and converts them into measurable electrical signals for monitoring, control or data analysis in various applications. Role of sensors in modern technology. Sensors detect and measure physical properties, enabling automation, data collection, and real-time monitoring, which are crucial for advancements in healthcare, transportation, and smart technologies. There are some key characteristics of sensors. Sensors detect physical or chemical changes, converting them into measurable signals. Key characteristics include sensitivity, accuracy, response time, range, reliability, and stability. They are essential for precise and consistent measurement. This is the introduction to sensors. Sensors are devices that detect changes in physical, chemical or biological conditions and convert them into measurable electrical signals. They play a crucial role in modern technology by enabling machines and systems to monitor and interpret and respond to their surroundings. Depending on their function, sensors can measure a wide range of parameters such as temperature, pressure, light, motion, humidity and gas concentration. This is the block diagram of sensor. It includes 7 types of blocks. The first block is sensing unit, then signal conditioning block, then ADC, that is analog to digital conversion, local user interface, application algorithms, memory, and communication unit, that is transceiver. So according to block diagram, the first unit is sensing unit. It senses the parameter, which is a physical parameter, or it detects the parameter and it passes that signal into the signal conditioning block. The signal conditioning block passes the signal which is coming from sensing unit and passes it to ADC, that is analog to digital conversion. The ADC converts the signal, that is analog signal, into digital signal and gives the signal to the application algorithm. The application algorithm do the process on that digital signal and it is stored in a particular memory. The communication unit, that is the last unit, is for data communication and it doing the work of transceiver, means it transmit and receives the signal. There are different types of sensors. The first type is temperature sensor, second is proximity sensor, third is pressure sensor, fourth is light sensor, fifth is motion sensor, sixth is gas sensor, and last is touch sensor. The temperature sensor measures heat or temperature. The example is thermometer or climate control. The proximity sensor measures distance to objects and the example is phones, that is the screen of near ear. Third sensor is pressure sensor and pressure sensor measures force over an area and the examples are tire pressure monitoring. Next sensor is light sensor and it measures light intensity. The example of light sensor is automatic brightness in phones. The next sensor is motion sensor, which measures the movement or acceleration. The example for motion sensor is fitness trackers or alarms. The next sensor is gas sensor, and it is used to measure the gas concentration. The example of gas sensor is smoke detectors or CO monitors. The last sensor is touch sensor, and it measures physical contact. The example of touch sensor is touch screen. There are some advantages of sensor, that is, first is accurate data collection. Second is automation and efficiency. Third is improved safety. Fourth is energy saving. Fifth is compact and portable. The first is accurate data collection, means the sensors provide precise and real-time measurements of physical or environmental conditions. The second advantage is automation and efficiency, means the sensors enable automatic controlling systems like smartphones or industrial machines, reducing the need for manual operation. The third is improved safety, that is, sensors detect hazardous conditions, that is, gas leaks, fire or machine malfunctions, helping to prevent the accidents. The fourth advantage is energy saving, that is, in smart systems, sensors help to optimize energy uses. For example, turning off lights when a room is empty. The last advantage is compact and portable. Many sensors are small and lightweight, making them easy to integrate into devices like smartphones and wearable. Here are some disadvantages of sensors, that is high initial cost. Next is power consumption. Next disadvantage is environmental sensitivity. The next advantage is limited range, and the last is data overload. In disadvantage of high initial cost, some advanced sensors and their systems can be expensive to purchase and install. Regarding the power consumption disadvantage, continuous operation of sensors, especially wireless ones, can lead to high energy usage or frequent battery replacement. In regardance with environmental sensitivity, sensors can be affected by environmental factors such as temperature, humidity, dust or electromagnetic interference, which may reduce accuracy. The next advantage is limited range, that is, many sensors have a restricted sensing range and may not detect objects or changes beyond a certain distance. The last disadvantage is data overload, that is, in large systems, sensors can generate vast amounts of data requiring complex processing and storage systems. These are some applications of sensors, that is, sensors are used in consumer electronics. Example of consumer electronics is smartphones, smartwatch. Then second application is healthcare. The example of healthcare are medical monitoring device, wearable health touch. Then automotive industry. The automotive industry means airbag systems, parking assistant, then tire pressure monitoring. The next application is industrial automation, that is in robotics and process control. And the last application is agriculture, that is in smart farming. In the case of soil moisture, temperature and humidity, sensors help to optimize irrigation and crop management weather stations. Also, the sensors are used in weather stations, in environmental sensors for climate data. Future trends of sensors are integration with AI, that is artificial intelligence, then wireless and energy harvesting sensors. Next is flexible and wearable sensors. Next future trend is in nano sensors, and last is IoT expansion. Regardless with AI, that sensors combined with AI which enable smarter data interpretation, predictive maintenance and autonomous decision making. In the term of wireless and energy harvesting sensors, the development of self-powered sensors that harvest energy from the environment, solar thermal vibrations to extend battery life or eliminate the need for batteries. In the terms of flexible and wearable sensors, advancement in material science will enable sensors that can bend, stretch and integrate seamless with clothing or skin. Future trend is in nanosensor, that nanoscale sensors will offer unprecedented sensitivity, enabling applications in healthcare. Again, the future trend of sensor is in IoT expansion, that is in massive deployment of sensors interconnected via the IoT, that is Internet of Things, enabling smart cities, homes, industries and agriculture. The conclusion of this presentation is sensors are essential for modern technology, enabling devices to detect and respond to changes in the environment. With ongoing advancement, sensors are becoming smarter, smaller and more efficient, driving innovation across many industries and improving everyday life. Thank you.